So for this one, we are looking first of all for the area of the region R for part A, which we then needed to figure out which function was above the other function. So which function is above the other function in this problem?
The 6 minus 2, the one with the 6.
Yeah, h of x is up here, right? This is h and this is g. We should be able to tell because this should be a parabola that is always concave down, which is what this looks like. And this one is a clearly not parabola, right? Alternatively, we should know that, if we plug, and we could just plug in x equals 0 to both of them. Plug in x equals 0 to this, you get 1. So there you go. If you plug in x equals 0 to this, you end up getting 4. So that makes sense. So in order to find the area, we've just got to do the integral. We'll put it on a new page. For part A, we just got to do the integral from 0 to 2 of our upper function, which was, what was it? 6 minus 2 times x minus 1 squared. And then subtract from that our lower function, negative 2 plus 3 cosine pi x over 2. So that was your setup. If you wanted to distribute all this out, you could, or you could just integrate it as is by letting u equal x minus 1 for, separating the different integrals and let u equal x minus 1. But I think, I don't know, how many of you guys separated into different integral and did a u substitution here and a u substitution here versus like just distributing it all out? Did you guys just distribute it all out?
I distributed all of it out and then did u substitution for like the very last term with the cosine.
Yeah, okay. So let's just go ahead and do that then. So this should then become an integral from 0 to 2 of 6 minus, and then x minus 1 squared times 2. So x minus 1 squared starts with an x squared term. So I'll just distribute the minus 2 to everything. So 6 minus 2x squared. And then it would give us a minus 2x, but we'll multiply that by negative 2 to give us a plus 4x. And we get a plus 1 times that is a minus 2. Distributing this negative gives us a plus 2. Didn't mean to do that, which those will cancel, right? And then a minus 3 cosine pi x over 2 dx. And so I hope at this point you can do this u substitution for this integral by yourself. I don't know why it keeps doing that. But if we integrate this all, we get 6x, we get minus 2/3 x cubed, we get plus 2x squared, and then this becomes minus 6 over pi sine pi x over 2. And then you evaluate. 12 minus 16/3 plus 8 minus, and this becomes sine of pi, which is 0. So 0 times 6 over pi is 0. And if I plug in 0 to everything, that's 0, that's 0, that's 0. And the sine of 0 is 0. So all that stuff is 0. We got 20, which would be 60/3 minus 16/3, which would be 44/3. And this area problem was actually worth 4 points. 1 for the right setup, 1 specifically for getting this integral, 1 for getting the rest of the integrals, and 1 for the final answer. Any questions there on part A? All right. Part B. Part B was asking us to find the volume of a solid that has this region as its base, and the cross sections perpendicular to the x-axis have this as their area. Well, it doesn't give us a shape, but it doesn't matter because what do we do with the shapes? We find their area and integrate those areas from 0 to 2 or whatever our interval is. They give us the area. So all we need to do is integrate the area from 0 to 2. What's the integral of 1 over x plus 3? Should be natural log absolute value x plus 3. We evaluate
That's what I
that
got.
from 0 to 2. We end up with natural log 5 minus natural log 3. Or natural log 5/3 if you prefer. That's it. That was a pretty straightforward one. 1 point for the setup and 1 point for the answer. Any questions on that? All right, let's take a look then at part C. So C says we're going to write but not evaluate an integral expression that gives the volume of the solid when we take R and rotate it around y equals 6. So this should be pi times the integral from 0 to 2 of our outer radius squared minus our inner radius squared. And so our outer radius is just the distance from 6 to this function. And our inner radius is the distance from 6 to the smaller function. And so that'd be 6 minus g of x and 6 minus h of x. So pi times the integral from 0 to 2 of 6 minus, now I forgot the g on the bottom, g of x squared minus 6 minus f of x squared dx. And that's good enough. If you wanted to replace the g of x and the f of x with the actual functions, you can. But if you leave it like this, that's also acceptable. And this was worth 3 points. 1 for the limits and the constant, and 2 for this. And the way they sort of indicated in the scoring guidelines actually makes it sound like if you tried to do an outer radius squared minus inner radius squared, they give you a point for just trying to do this in the right form, even if you had the wrong things inside of your radius. And then you added the right values of your radius to get the actual last point there. And that's it. Any questions on any of that, A, B, or C?
So in general, is it acceptable to do things where like you leave like f of x in, or like use a instead of a number? Like that's okay if there's long things that you don't want to write?
Yep, as long as it says, you don't need to evaluate it, just leave it like this, that's fine. Or if, as long as you define, like if you have like a, a decimal that's 9 decimals long, as long as you define it as A, you can just call it A throughout the entire rest of the problem, and that's totally fine.
Thank you.
Yep. I guess the question for all of those things in the chat has already been answered. Anytime. You're going to give them the answer to part B anytime. Hopefully only that part B, not part B on the quiz. That'd be cheating. Anybody have any other questions?